let's talk about linear word problems, which really just means word problems that involve a linear equation or inequality. So what we'll do for these notes is check out a few examples of word problems that need to be solved by writing an equation or an inequality and then solving that equation or inequality. So the kind of basic steps here for solving this type of problem, you want to read through the entire problem first before you do anything else. Just read through the problem and try to understand what it's asking you. Highlight or underline important information as you do. That way you can keep track of things and know where they are in the problem. And then decide what your variable stands for. It's usually what the problem is looking for or what you're being asked to find. That's going to be what your variable is going to stand for. And then you write and solve an equation or inequality. And that will usually either lead you to the right answer or let you then find it. So let's get started. So it says Jack is thinking of a number, 8 more than the product of 5, and the number is 93. Find Jack's number. So Jack's number, that's going to be our variable. And we can call it x or n or whatever. And it says 8 more than the product of 5, and the number is 93. So let's go ahead and make Jack's number n. We'll use the variable n for that. And so we'll build our equation based on what it says in the sentence here. 8 more than the product of 5 and the number. Well, the product of 5 and the number is just 5n, right? 5 times the number, which is n. 8 more than that is 5n plus 8, and it is 93, so equals 93. So that's our equation for this problem, and now we simply solve this equation to find n, which is Jack's number. So let's subtract 8 from both sides. We get 5n equals 85. Divide by 5, and n equals, let's see what 85 divided by 5 is. That is 17. So n equals 17. So our solution, Jack's number, is 17. Let's keep going. Mrs. Gadget's car broke down on the highway. It cost $30 plus $3 per mile to tow her car. If she paid $162 total, how far was the car towed? So we're trying to find the number of the distance, right? The number of miles that her car was towed. So let's use that as our variable. Let's make it m. So it cost her $30 plus $3 per mile, and she paid $162 total. So for the equation, let's start with this expression. 30 plus 3 per mile. So that's 30 plus 3m. And her total was 162. So we can solve this equation to find out the number of miles it would take for that all to equal 162. So let's solve it. Let's subtract 30. So we get 3m equals 132. We're going to divide all that by 3. And that's going to equal 44. So our solution here is 44 miles. If you're ever not sure if you got the answer correct, you can just plug it back into your equation and check it. If you're not confident that your equation's right, read back through the problem and see if it makes sense. Okay, example C. Brenda has $500 in her bank account. Every week she withdraws $40 for expenses. Without making any deposits, how many weeks can she withdraw this money if she wants to maintain a balance of at least $200? So kind of a lot going on in this problem. She has $500 total. Each week she withdraws $40. That's important. A withdrawal is a negative amount, right? She's taking that money out of her bank account. She's not making deposits, so her total money is not increasing. We want to know how many weeks. So that's going to be our variable, W. Can she withdraw this money if she wants to maintain a balance of at least $200? Okay, so we know we're going to have an inequality here because it says at least. So let's start with the initial information. She has $500. And every week she's taken out $40. And W, weeks, is our variable. So we're going to subtract 40 per week, so 40W. Now this amount, 500 minus 40 per week, has to be at least $200, right, left over. So this expression needs to be no less than $200, right? So this needs to be greater than or equal to 200. Because if this amount ever goes below 200, right, that fails the situation. So this amount, 500 minus 40W, has to stay at least or greater than or equal to 200. So there's our inequality for this problem. Now let's solve it. We're going to subtract 500. So we get negative 40W is greater than or equal to negative 300. Let's divide by negative 40. Now don't forget, for an inequality, whenever you divide or multiply by a negative, you have to flip your inequality symbol. So we get W. Flip the symbol, is less than or equal to. Now negative 300 divided by negative 40 is 7.5. Okay, so our answer to the inequality is W is less than or equal to 7.5. Now let's think about how that works with what the question asked us. It says, how many weeks can she withdraw this money if she wants to have at least $200 left in her account? Well, she's doing this once a week, so 7.5 won't really work. So we know it's either going to be 7 weeks or 8 weeks, okay, because it's somewhere in the middle. Now, because she wants her account to stay above 200, this has to be 7 weeks. Because if we go to 8 weeks, it's going to be too much, right? That'll be, she'll take out and she'll have less than $200 left. So in this case, we shouldn't round up. We should leave it at 7 weeks. So that's our solution there, 7 weeks. Because 8 weeks would be too much, because our solution has to be less than or equal to 7.5. So the biggest integer that's less than 7.5 is 7. Okay, next one here. Jane receives an allowance of $3 per week. In addition, she can earn $2 for each chore she does. So here we have to be careful because we have two kind of per things. We have $3 per week and $2 per chore. So we have to make sure that we read the question carefully to know which one is going to be our variable. This week, she wants to earn enough money to buy a CD for $13. Write and solve an inequality to determine how many chores she needs to do this week to purchase the CD. So we know how many chores, that's what the question is asking us to find, so that's what our variable is going to be. So she gets $3 this week, plus the 2 per chore, and she wants it to total $13 or more. You know, she can earn more than 13, but she wants to have enough money to buy a CD. And we want to write an inequality because it says so. So that's what this should say here. Inequality. So let's build that inequality. So she gets $3 per week plus the $2 per chore, so 2C, and she wants to have at least $13. So this amount, 3 plus 2C, needs to be greater than or equal to 13. Okay, so that's our inequality. Let's solve it. Subtract 3 from both sides. 2C is greater than or equal to 10. Divide by 2. And C is greater than or equal to 5. So she has to do, how many chores she needs to do this week? She needs to do at least 5 chores. So let's say 5 chores. And because it wanted an inequality, let's say at least 5 chores. Because, you know, if she does more than 5, she'll just have leftover money. Not a bad thing. So she'll have to do at least 5 chores this week to get enough money for that CD. All right, now let's talk about another type of word problem, consecutive integer problems. So when we say consecutive integer, a consecutive integer, those are numbers that are right next to each other, like 1, 2, 3, and so on. And this can also be expressed using variables such as n. If n's the first number, then the next number would be n plus 1, and then n plus 2, and then n plus 3, and so on. Because for every new consecutive number, it's one more than the last one. If we talk about consecutive even integers, that's like 2, 4, 6, and so on. Expressing those with variables would be like n, and then the second number is 2 more than the first one, so n plus 2, n plus 4, n plus 6, and so on. Okay, so each new number is 2 more than the previous one. Consecutive odd integers, these would be the odd numbers, like 1, 3, 5, 7, and so on there. Now, these expressions would actually be the same as the even ones, because if the first number is n, the second one is also 2 more than the first one. So as far as the math is concerned, even and odd integers look the same. They are all 2 apart. So when we have to write a problem or an equation for a consecutive integer problem, you want your variable to stand for the smallest number. That's why we start here with n, and that's going to be the easiest way to think about these numbers. And then you use expressions to base each number on the previous one, or its relation distance from the first number. Okay, so let's try it. Find 3 consecutive integers whose sum is 42. All right, so we have to think about this a little bit. For our equation, we have 3 things to add together. So just to show down here a little bit, we're going to add 3 things together. Maybe I'll do it on this side. 3 consecutive numbers, and they add up to 42. Right? That's the situation we have. They have a sum of 42. And they're consecutive integers, not even, not odd, but consecutive integers. So like the first row up top. So if our first consecutive integer is n, the second one has to be n plus 1. And the third one has to be n plus 2, because each one is 1 more than the previous one. And since we only want one variable in our equation, we just base each new number on its distance from the first one. So the second one is 1 away, and the third one is 2 away. Now we can simplify this equation a little bit by combining the n's and the 2 and the 1. So our final equation is 3n plus 3 equals 42, right? Because if you combine like terms here, there's 1n here, 1n here, and 1n here. That's 3n total. And then 1 plus 2 is 3, and that equals 42. So here's our equation. Now we solve it. So 3n equals 39, divide by 3, and n equals 13. Now remember, we have 3 consecutive integers, and we have to find all 3 of them. We found the smallest one is 13, which means the second one is 14, and the third one is 15. Right? And just to remind you, our expressions were n, that's 13, n plus 1, 13 plus 1 is 14, and then n plus 2, 13 plus 2, that's 15. So it all works out. Let's try example F. 4 consecutive even integers this time. So we have 4 of them. They're even. They have a sum of 60. Find the smallest number. Well, again, let's just do some work over here. We're adding 4 things together, and that equals 60. If the first one is n, and they're even, the second one is going to be n plus 2. The third one's going to be n plus 4, and then n plus 6. Because remember, they are even numbers. And so each new number is 2 more than the last one. Okay, let's combine some like terms. So we have 4 n's this time. 2 plus 4 plus 6 is 12, and it equals 60. So there's our final equation. 4n plus 12 equals 60. Now we just solved to find the smallest number. So let's subtract 12 4n equals 48. Let's divide by 4, and n equals 12. Okay, so that's our first number. We just have to write down all four. So if the first one's 12, the second consecutive even integer would be 14, and then 16, and then 18. So there are four numbers there. Okay, last one here. Two consecutive odd integers have a sum that is at most 56. Okay, well this should actually say inequality here. This is actually going to be an inequality here because of the words at most 56. And then find the pair of integers with the greatest sum. So we have two consecutive odd integers. There's only two of them. They are odd, and they have a sum of at most 56. So let's figure that out. We have two things to add together this time. N, and since they're odd, n plus 2, right? Odd numbers are also 2 apart. And it is at most 56. At most means it can't be more than that. So it's up to 56. So this needs to be less than or equal to 56. So our inequality is 2n plus 2 is less than or equal to 56. So there's our equation there. Let's go ahead and solve it. So let's subtract 2. So 2n is less than or equal to 54. Dividing by 2 gives us n is less than or equal to 27. So what this means, remember n is our smaller of the two numbers. So it means that our small number n has to be less than or equal to 27. So any odd number less than that or equal to it would have a sum less than or equal to 56. But we're being asked to find the pair of integers with the greatest sum, which means our n can be equal to 27, and that will be the biggest number. So 27 and the next odd number would be 29. And if you add those together, that does equal 56, which would be the greatest total that fits this criteria, at most 56. So 27 and 29 for our two odd numbers. So there you have it. Word problems using linear equations and inequalities. Read through the problem, find the important information, decide what your variable stands for, and then write and solve an equation or inequality to find your solution.